Hello, welcome to my demo for the Coder School. I'm Coach Joe, and this is part 1 out of 4 of my Intro to GameDev series. When you're coaching a student, you always want to work on the platform of their choice. So this scenario is for the student who wants to make a game, but they're undecided of the platform. They want to make a browser game. They want to make a Flash game, so you can explain that Adobe isn't supporting Flash any longer, and Canvas is kind of the replacement. This demo would also work for the student who wants to make a game in the Phaser framework. Some quick pros and cons for Canvas. First, pros. No experience is required. The student doesn't have to have any programming experience to work in HTML5 Canvas if they want to make a browser game. This also applies to Phaser and other things. Also, your development environment for this demo is pretty flexible. I'm going to be using JS Fiddle, but you could just as easily use Replit, or if they have a text editor, I recommend Notepad++ and Sublime Text. If they have one of those, then you could just code with a project file on their desktop, and if you drag the HTML file into their browser window, then that'll open their game in the browser as well. So the development environment is pretty flexible for this demo. Also, this demo is great for learning web development. I've even had students that go this route start asking more server-side questions, like how would I store people's account information if they logged into my website? And then you can even learn Node.js with them. And these lessons have a lot of applications to like a web development career path, which is really great. Also, there are a lot of online resources, like besides official documentation, which you really want to be going to MDN as a resource, there's also things like W3 schools, and there are a lot of forum answers for this kind of thing. So some cons for Canvas. I would definitely describe it as a medium to low difficulty route, as opposed to the other 3 videos in this series where you're using an engine. If you're using Canvas, it takes a lot of steps until something is rendered on the screen, like something that's actually interactive and something you could call a game. And that's a problem because the original advantage to learning coding through game design is that the student can like edit their code and they immediately see a change in the screen, like an actual graphical result. And there's a little issue with Canvas where you won't get to that point until maybe the end of the first session. It's going to take a while until it's like a playable game. And that sort of leads into my next point, sort of a reiteration of my last point. The learning curve is a little steep. I would call it steep-ish for this demo. And that's because you have to give them a lot of code, and they will sort of be watching your process before they can develop their own process. So yeah, that first lesson, I do a lot of like annotation with Zoom on their screen. So I'll like annotate the code that I sort of want them to copy. And you want to get past that point to where they're actually writing the code themselves. And that'll definitely happen in like at least the second session. This entire demo I'm going to do in this video is going to take the student anywhere from 1 to 4 sessions. But after that first session, after that first trial, the narrative is going to reverse. You're going to start asking them, okay, what's next? You're asking them what the feature they want to write is. But for the first session or couple of sessions, you're going to need to be giving them a lot of the code because they just don't know where to look for it. And the third con is that Canvas is restricted to 2D. And you can get around this. You can make a 3D browser game if you're using something like 3.js. That's pretty advanced though. And if the student really wants to make a 3D game, I would just suggest an engine like Unity. Okay, so let's jump right into Canvas. So first off, we're going to be using Model View Controller Framework. There's a Wikipedia article on it, MVC. We don't have enough time to explain object-oriented programming, even though object-oriented programming is really important for game design. There's just not enough time to explain it in the first session. So first, we're going to have them write comments. Well, actually first you can have them pull up the JavaScript portion. We're only going to be writing JavaScript for this demo. The HTML and CSS is already given to them. Okay, so first we'll explain how to write comments with 2 slashes, and we'll write model, controller, and view. This is to separate their code into 3 parts. You want to get to the point where there's something on the screen in the first session that they can interact with and like see an immediate result to their code. So in the first session, you want them to write about minimum 100 lines of code. They might write up to 400 lines, depending on how far you get in the first session. But if they aren't at that point, you can like start speeding it up by like having them copy paste bigger code snippets. And then you can return to those code snippets in a later session. But the important thing is that in the first session, you get to like a playable demo point. So in the model, we're going to explain the var keyword, and we're going to write some variables. These first variables are just going to be practice with them copying what you annotate on the screen. Because these lines of code are pretty long, and there's not much you can explain about them except that this is what you need to do to get the canvas tag referenced so that you can start drawing things on the screen. So var canvas equals document.getElement by ID canvas. And then the next variable is also part of referencing the canvas. So we're going to say ctx equals canvas.getContext 2D. Okay, they don't have to indent the first variables, but later we're going to be a bit pickier about style because it'll be helpful for them to get the style right off the bat. Okay, so yeah, they don't need to indent these variables, but the next variable is easier to understand. It's width equals window dot inner width. So you'll be writing this, you'll annotate this on the screen and they're going to copy it again. This is easier to understand. We're just getting the dimensions of the screen, the result screen, so we can know its dimensions. And then you don't have to type the next part on the screen. You can just say, well, what do you think the height is going to be? And we say height equals window dot inner height. So it's exactly like the width. You can tell them it's exactly the same. Just type height equals window dot inner height. Okay, next we're going to make a player object. And we're going to write a bunch of player variables inside this object. And you can explain that to write a variable inside a variable within a variable, you use a colon now instead of the equal sign. And that will be referencing these with player.color, player.x, player.y, etc. But yeah, so they can pick their favorite color here. I'm just going to say color red. And then x is going to be, we're going to use the width variable we already declared. So width divided by 4. That's just saying their default position is going to be at 1/4 of the screen width. So you see my cursor, it's about here. And then y height minus 50. So this is going to start them at the bottom of the screen. I should explain that the top of the screen here is 0. So the top left is 0, 0 coordinates. So to get them at the bottom of the screen, you can get the full height of the screen. And then we say minus 50 because in JS Fiddle, there's this little black bar at the bottom that's going to cover the player if you don't do the height minus 50 thing. Yeah, that's 50 pixels high right there. Okay, so then after the y, we're going to say that the width of the player is 10 and the height is 10. That could also be different if they want to make it the player bigger, but 10 is fine. Okay, so speed, we'll say 6. Also just, that could just be a preference. And they can tweak these variables later. That can be a fun exercise. You can say, well, how would you increase the player's maximum speed? And that's sort of just quizzing them on it, and they would change this number here. Okay, and then velocity is kind of hard to explain, but we need it to do the physics calculations. So I'm gonna set the initial x velocity of the player to 16, so that right when we play the game, the player is going to move a bit, so you can know things are not crashing. That could just be 0. The velocity can be 0. So vel y is 0. And you can just explain velocity as like, kind of like acceleration. That's almost correct. Okay, so after velocity, we'll say jumping equals false. That's the last player variable we're going to write. It's just a state variable that says when they're jumping or not. So we'll set it to true when we don't want them to have the ability to jump in midair. Jumping just tells us if they're already jumping or not. Okay, so then a comma after the object curly brace. And then a few more variables for the model. We're going to say keys equals empty array. You can explain an empty array, or you can explain arrays as like a collection of things. So this is just where we'll be storing our key presses. Next, physics variables. Friction equals 0.9. And gravity equals 1. Friction is just to make the player a bit slippery, like Super Mario Brothers. And gravity, of course, you don't need it if you don't need these variables if you know the student wants to do like a top-down bird's eye view 2D game. But we're doing a platformer, so we're going to have friction and gravity. Okay, so we're done with the variables. Now we'll write canvas.width equals width. So we are setting the canvas to the width and height of the screen that we got earlier. So canvas.height equals height. Okay, and that's actually it for the model. So we're about a third of the way through, and you can tell them that because in my experience, the students like to have like checkpoints to know what their progress is on their game. But yeah, you can tell them we're about a third of the way through because we got through the first comment. Okay, so now we're in the controller, and we're going to write an update function. This function is going to happen every frame. So function update. This code will run every frame. Make sure they have a ton of space here to write code. So a bunch of new lines. And then they'll write a new comment, an indented comment. Check keys. Okay, now we're just going to be doing some key press code. And we're going to be supporting WASD and the arrow keys. So they can write another comment that this is going to be the, what is this? I think this is the right arrow key and the D key, right arrow and D. So if keys 39, and then we're going to teach them about the OR operator. It's these two vertical lines above your enter key. You have to shift and press the backslash, and you can get these vertical lines. That's the OR operator. So we're saying this key or that key is being pressed, or keys 68. So if keys 39 or 68. And this is from the documentation. You have to give them these numbers because there's no way they're going to figure this stuff out on their own. I mean, they could, but if they're not Googling it, they're not going to know what those keys are. So inside that if statement, we're going to write another if statement. So if player.velx is less than player.speed, then do something. So far, what are these if statements saying? They're saying if this key or that key is pressed, if the right arrow or D key is pressed, and if the player's X velocity is not at their maximum speed yet, then increase their X velocity. Increasing their X velocity makes them move right. So player.velx plus plus. If you don't want to do plus plus, plus plus is just a shorthand for plus equals 1. So you could show on their screen that plus plus is equivalent to saying plus equals, or you could also say player.velx equals player.velx plus 1. That also works, and that would probably read the most clear. But player.velx plus plus is also fine. Okay, so now you can have them copy this whole part for the other key press, because the left movement is actually pretty similar. So we're going to copy that, write a new comment, left arrow or A. And these keys are going to be key 37 and what was the other one? Key 37 and 65. So left or A is key 37 and 65. And then we're going to reverse some of these things to move them leftwards instead of right. We're going to say player.velx is greater than negative player speed. So you put a minus sign in front of player speed. Instead of less than, it's greater than, and then you negate the player speed. And then we'll say player.velx minus minus. So that's all we have to do for that key press. Now we're going to be doing jumping. So we're doing if keys, what was jumping? You can also go to the documentation at these points where you need to look at the documentation. It's a pretty good exercise to be constantly going to the documentation for answers, because all of the answers are there. So if keys 32, and if, another if inside that if bang player.jumping, you need to explain that the exclamation point is reversing the either false or true value of player jumping. So it's saying if not player jumping, if the player is not jumping. And then inside that if, all we write is player.jumping, we set it to true so that they can't jump midair. Player.vel_y equals negative player.speed. Because 0 is at the top of the screen, we use negative values to make the player move upwards. Okay, so that's all we have to do for that code. And you can change the jumping code later if you want to like have them write a double jump. Double jump is like a pretty good exercise. You could do it at this point or in a later session. It's a pretty good like quiz question, like how would you do double jump? And then you can see if they can do it. Okay, so we're done with key presses for now. Now we're moving on to physics. So write a comment physics. And we're doing player.velx times equals friction. Player's X velocity times equals friction. If you think it would be simpler for them, you could also do player.velx equals player.velx times friction. That also works. And the same for the gravity. You could do player.vely time or plus equals player.vely equals player.vely plus gravity. But we're going to do player.vely plus equals gravity. Less code. Okay. So next for physics, we're doing player plus equals player.velx. So this is what actually makes the, player.x plus equals player.velx, and player.y plus equals player.vely. And this is what makes the player actually move every frame based on their velocity. So the amount of velocity is going to change how much they move by. Okay, so now This is also where you would write platforms code, so we'll come back to this. You can put a comment there if you want. Platforms. Okay, and what's next? And this is also where we can check player in boundaries. So this is where we can keep the player in the boundaries, but don't write this code yet because we need some helper functions before we can write this code. So we're just going to write placeholder comments. The check player in boundaries is the only placeholder comment you need right now, just so they remember that we're coming back here. Okay. So now, now we're going to say a new comment, ready to jump. This is the code that says the player's touching the ground, so do something. So if player.y is greater than or equal to height, height minus player dot height, height minus player dot height. Yeah, I think that's right. Or minus 50. If 50 was the ground, yeah, because we have, again, we have this black bar here on JS Fiddle. So you need the minus 50 as well, because our ground is 50 pixels above the ground. So inside this, player.jumping equals false. That's the only line you need inside that if statement. It just resets the player's ability to jump when they touch the ground. Okay, and we're actually done with the controller for now. So we're moving on to the view. And the view is actually inside of update as well. So keep view inside of update. This is just where we're going to be rendering things graphically to the screen. So first, ctx.clearRect 0, 0 width height. So this just uses the variables to get the screen width and height to clear the entire screen every frame before we draw more stuff. And this is something you have to do in Canvas. So yeah, so that's just like that. Okay, so CTX clear rect. Next, we pick a fill style. Every time you draw something in Canvas, you need to pick what color you're drawing with fill style. So fill style equals player.color. That's that red variable we set earlier. So it's just a string that says red. Next, we're going to be drawing the player at their position with their width and height. So they're just a rectangle. So all we do is ctx.fillRect player.x, player.y, player.width, and player.height. Okay, is that right? Yeah, that looks right. Always remind them to do semicolons if they forget. I don't think JavaScript will always break if you miss a semicolon, but we want to get them into like good habits. Okay, so what's next? Now, this is kind of like recursion, but I wouldn't explain recursion every time because recursion's like confusing. We just use set timeout to call the update function at the end of the update function. So it calls it again. And we're calling it at a rate of 1,000 milliseconds divided by 60. So it's going to be a 60 frames per second game. That's standard. Okay, and then to close out this update function, okay, you do an ending curly brace. Oh wait, do we already have that? Yeah, we already had that down there. Okay, so you've got your ending curly brace, and then you can do an opening and closing parentheses just to call update after you declare it. Actually, guys, I realized that 1 is probably too much gravity, so let's put it at 0.5. It won't break anything, but I think 1 was too much gravity, so yeah. back down in the ready to jump comment, have them write ready to jump, and then say if player.y. You can either tell them this verbally at this point, or you can put it on their screen as an annotation. Either way, if they're not getting it verbally, it's okay to write an annotation. So if player.y is greater than or equal to height minus 50. So if the player is touching the ground, we're just going to reset their ability to jump by saying player.jumping equals false. And the ground is 50 pixels above the bottom of the screen, because remember, this black bar is here. We don't want the player to be behind it. Okay, so they're actually done then with the controller. So 2/3 of the way through. Move the view comment up into the update function, because we're actually going to be doing graphical stuff, like rendering things. We're going to do that in update as well. So first off, in view, we're going to say ctx.clearRect 0, 0, width, and height. And this just clears the screen every frame, because that is something you have to do in Canvas. You have to clear the screen before you draw more things. Okay, so ctx dot fill style equals player dot color. This is just using the player dot color variable we declared up in the player object. So it's that red string. It's just a string. You need to select the brush color before you draw anything in Canvas. So ctx.fillRect, we're just drawing the player here at their position. ctx.fillRect player.x, player.y, player.width, and player.height. So we're just drawing the player as a rectangle for now. Okay, and then after that, we'll actually be using recursion here, but I wouldn't explain recursion every time because it's kind of confusing. But we are calling update inside of the update function. So at the end of update, we just call it again at a rate of 1,000 milliseconds divided by 60. So this will call it at 60 frames per second. All the code in update will run 60 frames every second. And then I think we already have the ending curly brace for update. So get that there. And then open and close parentheses, and then a close parentheses and a semicolon. So that just runs update once right after you're declaring it. So then it'll keep going. Okay. So that's actually pretty good. So let's test it out. Let's see what happens when we test out the game. Run. Okay, nothing happened. Oh wait, yeah. So the player did show up for a second. You can kind of see a red square. So things are working, but I wouldn't really call this like a good stopping point because it's not really playable yet. So we're going to give them two functions. I have them here. You can just type this in the chat for them and have them copy it. But actually this clamp function, we're going to put this at the top of the code. This is kind of a good puzzle if you have time for it. This is a good puzzle to have them figure out how they would write it. And I use a ternary operator here, but this is a lot easier if you just use like multiple statements. It's just checking that the player is in the boundaries of the screen, and it's making sure that they stay there. So this is what we'll be using for collision as well. And I think it's a good function to have them write if you think they're up for it. But we're going to put this at the top of the screen. We're going to say number.prototype.clamp equals function min max. And then there's my ternary return. So yeah, this would look different if they write it, unless you want to teach ternary operators, but that's more like an advanced topic. Okay, and then one more function, this time at the bottom of the screen. This is just a helper function to get our key presses. So on key down, it stores the key in the keys array. Okay, so before the player will actually land on the ground, we need to write the collision code for the boundaries. So if you remember, we made this comment, check player in boundaries. So right there, we're going to say player.x equals player.x.clamp, and 0, because 0 is the top of the screen. Oh wait, no, this is the left side of the screen because we're on the x coordinate. So player.x equals player.x.clamp, 0 width minus player.width, and then the y is pretty similar. It's just player.y equals player.y.clamp. And then for the upper bound for this one, you can say -50. I say upper because it's the top of the screen. I'm putting it a bit above the top of the screen because it kind of is nice in a platformer when you can jump over the boundary of the screen. It's kind of nice. Like Mario has that, Mario Brothers. So -50, and then the bottom of the screen is height minus 50. Yep, I think that's right. Okay. So now what does it look like? Now the player's actually on the ground, and they can jump around. And yeah, that's pretty much all they can do for now. But this is a good stopping point for a first trial or a first session, I think, because this is actually playable. Like now if they change the physics variables, they can actually like play around before your next session with them. They can mess around with this code a bit because it's actually playable now. So this is actually a good stopping point, but if you still have time, obviously keep going. So what's next then? Next, the most obvious thing to add is platforms. Their game might not call for it, but it's just the most like common scenario. And this kind of game at this point could become any kind of 2D game. So it's really like a flexible thing in Canvas. So now we're going to do platforms. So we're going to go back to our platforms comment right here. You might have not written this comment yet, but you should put it right after the physics and before you check player boundaries, because just like player boundaries, it's another type of collision code. So we'll put similar code in the same spot. And this is where you're going to teach the concept of a for loop. Okay. So for, oh, actually, before we do this, we need to create the platforms in the model. So we're going to make just some example platforms. Let's make a new variable. So var platforms equals, and we're going to use a 2-dimensional array. So var platforms. You can also write a comment that the platform arrays are going to be storing the platform's x, y, width, and height in that order, because all we need to do with them is like define a rectangle. So x, y, width, and height. Okay, so then let's say the first platform is like 120x, maybe 100y, could also be 100 width, and let's say like 20 height. So there'll be a thin platform. And then the other platform can just be the same size, but in a different spot. So we'll say like 300, 300, 120. So just have 2 platforms to start. And then they can do more level design in this portion by adding more platforms. That's another good assignment to give them outside of class. Okay, so now we're going to be checking the collision with the player on these platforms, and then we're going to be rendering the platforms. it could be better to render them and then do the collision, because you know, like, it's a good step to render it, and then you can run the game and check that they're in the right spot and that there's no errors. So, okay, so now we're going to get started on our collision for loop. This is the platform collision for loop. We're only going to be doing top collision because it's the most important. This is so that the player can stand on the platforms. We don't care about left, right, and bottom collision yet. So for I equals 0, starting at the 0th platform, I is less than platforms dot length. So you can explain that this for loop will loop as long as I is less than platform's length, meaning we're going to touch every platform in this for loop for the platform collision. Check the player's collision against every single platform in the scene. So I++ to increment it by 1. And then we're going to say plat equals platforms I. Just so we don't have to keep writing platforms I every time, we can just say plat equals platforms I. Okay, and then we're going to write an if statement. So if player.y is less than plat 1, plat 1 being the platform's y coordinate, plus player.height. So this is just making sure the player is above the platform. We don't want to do collision unless they're above the platform. Okay, so inside that if statement, another if statement, if player.x plus player.width is greater than plat 0. And maybe I can annotate to make this more clear why we're writing the first part of this if statement like this. It's because we want the player to be caught by the platform, even if their x coordinate is a bit to the left. We want the player to be like able to hang off of the platform. So that's why we say the plus player width. Okay. So clear all drawings. Oh gosh. Okay. So now we're going to do 2 more conditions inside this if statement. So you can write and then keep doing it on one line, or you can separate this if statement into multiple lines and just indent the other conditions. So a double ampersand for and then we're going to say, okay, now the right side, so player.x, player.x is, player.x is less than plat 0 plus plat width. And again, we have the plat width included here because we want the player to be able to hang off the edge. Or actually, no, it's because this is the right side. This is the right side of the platform. We add the platform's width to the x. But yeah, they will be able to hang off the edge with this. Okay, so double ampersand. And next condition, player.y plus player.y velocity, so vel y, is greater than plat 1 minus player.height. Okay, kind of a huge if statement, but you know, it's debatable whether this looks cleaner than 3 different ifs or not. So what this last condition is saying is we're adding the player's y position to the y velocity because we want to preemptively know that collision is going to happen in the next frame. We don't want to check the collision after something bad has already happened, where like they're already overlapping. This is just a better way to write collision, where we're asking for permission, not forgiveness, right? Okay, so inside of this now, we're going to say another if statement. Yes, another if statement. Oh, let's move that one a bit. Okay, so if player.vel_y is greater than 0, meaning they're moving downwards, this means that the player is falling. We only want to do the collision if they're falling already, or if they would be falling if there wasn't a platform there. So if player.vel_y is greater than 0. Now inside that if statement, we're going to do a clamp function. Just like our clamps earlier that kept our player in the boundaries of the screen, this is going to keep them within the boundaries of, say, the top of the screen and the platform. So player.y equals player.y.clamp. And then the parameters for that clamp also gonna be -50, so above the top of the screen. And then plat1 minus player.height. It's a little jumbled here because JS Fiddle is small. Okay, so that's that clamp. And then just like when we touched to the ground earlier, we're going to set player.jumping equals false. You know, resetting the player's ability to jump because they touched a platform, just like when they touch the ground. Okay, and then player.vel_y equals 0. So we're making sure that they're not falling anymore when they're touching a platform. Okay, so let's make sure there's no errors. Okay, there's no errors. There should be invisible platforms in this scene now, but now we can render the platforms. And again, you could have done this in reverse order to be more clear. You could render the platforms and then do the collision. Either way. Okay, so actually they can copy the first 2 lines of this for loop for this part, because again, for rendering the platforms, we're going to be looping through all of them. Okay, and then in your view portion, you need to put this after the clear rect, obviously, but you need to pay mind to the order in which you're drawing things to the screen. So this is more like preference, but I personally want the player to always be rendering above platforms. So I'm going to have the player render after the platforms render. The order matters here. That the things that come afterwards will render on top. So now the for loop. For I equals 0, I is less than platform's length, I plus plus. Plat equals platform's I, just as a shorthand. And now we're just going to be rendering a fill rect. Well, actually, you can pick another fill style. So let's grab this fill style. And let's just say like gray, or maybe we can say brown. I think brown will work, yeah. So the platforms will all be brown. And now we're just going to use another fill rect. So ctx.fill rect. And then we put the platform parameters in such a way that we can just put the parameters for the fill rect in order. So we can say plat 0, comma, plat 1, that's the x and the y, and then the width and the height are 2 and 3. So plat 2 and plat 3. Okay, so that should be good for that for loop. So let's check the result. And there they are. Oh wait, actually they're red. Maybe there isn't a brown. What if I do blue? Okay, yeah, now the platforms are blue. And it looks like that platform is a little under the screen. What you can do without changing the coordinates of the platform is you can pull up this window and then it'll draw a new screen height. So that platform will be higher now. So let's test that oh, okay. All right, we're colliding. So this is great. This is a great point to get to. If they get to this point in the first trial, that's great. It has happened before. If it's also an hour-long first session, this is another great point to get to. But you should be going at their pace. So it's okay if it took like 4 sessions to get to this point, as long as they're learning. But now this game is going to become any kind of game that they want. It can be any kind of 2D game, or you can move on to something else. But this is going to teach them a lot of fundamentals. So, yep, I hope that you enjoyed my demo. Good luck coaching.